Hi all, today I gonna introduce to you all chapter 11 about deformation of solids. For today's lesson, we only focus on stress and strain.
Today's learning outcome for lesson 12 about stress and strain is distinguish between stress and strain for tensile and compression force. Deformation of solids. Deformation can be defined as a matter changes its shapes or size under the action of an external force. You can see the diagram below that show the action of external force such as tensional force and compression force. Okay, yes. Forces not only cause acceleration but can also cause changes in the inner structure of solids. Such changes are called deformations. When an external force is applied onto an object, it will change in shape or size. Stress and strain. Stress is defined as the force per unit cross-sectional area on a body that tends to cause it to deform, or you may define by using the given formula in the slide, which is sigma equal force per unit area, where sigma is a symbol of stress. Stress is a scalar quantity. The SI unit for stress is kilogram per meter per second square or Newton per meter square or Pascal. Strain, the symbol for strain is epsilon, is defined as the fractional change in the dimensions of the object. As shown in the given equation or formula, strain is equal elongation per unit original length equal to difference in length, that is final length minus original length divided by original length. Strain is the deformation of materials in response to stress. Strain is a scalar quantity and dimensionless. Tensile and compressive stress and strain. Tensile stress and strain. Consider a rod that initially has uniform cross-sectional area E and length L0. Stretch the rod by applying the forces of equal magnitude F tangential but opposite direction at the both ends, and the rod will extend by amount E as shown in figure below. Tensile stress is defined as the ratio of the perpendicular force to the cross-sectional area E, or as shown in the given equation or formula below. Whereas tensile strain is defined as the ratio of elongation, also known as extension E, to the original length L0, or as shown in the given formula below. Compressive stress and strain. Consider a rod that initially has uniform cross-sectional area E and length L0. Compress the rod by applying the forces of equal magnitude but opposite direction at the both ends, and the length of the rod will decrease by amount E as shown in the figure below. Distinguish between stress and strain for tensile and compression force. For tensile stress, it occurs when equal and opposite forces are directed away from each other, whereas for compressive stress, it occurs when equal and opposite forces are directed toward from each other. For tensile stress, it causes tension, but for compressive stress, it causes compression. And again, for tensile stress, it depends on stretching forces, whereas for compressive stress, it depends on squeezing forces. Have a look at this process where showing clearly about bending is combination of tension and compression. Thank you and good luck.